And what we're going to talk about here is the compound interest formula. Yeah, it turns out taking the variable of your compound interest to be the time you're leaving an investment or a loan sort of thing. If that's your variable, the time, then it turns out this is an exponential function, the compound interest. You know what I mean by compound interest? That means, say we're doing monthly compounding of our interest. That means, month one, start with $5,000, and then month two, I've got to get $1 of interest. Well, in month two, I calculate the interest not just on the 5,000, but on the 5,001. And then when I say I get it up to $5,005 in month two, then I take the interest on the 5,005. Whereas in simple interest, you're just getting the interest on the 5,000. Compound interest, you're getting interest on the interest. Hence the name compounding interest. So anyway, here's what it works out to be. The formula works out to be this. If in an account with principal P, that's just the amount you start with, in an account with principal P with interest rate R that is compounded n times per year, the amount in the account after T years, the amount A is what we'll call it, after T years is given by this formula. A equals P times 1 plus R over N raised to the N times T power. Okay. Yes. Probably should. I actually put this, I don't put all this on here, but I put the formula on the test for you. But yeah, you should probably hang on to that one or know that one, what it means. Okay, so what this means is, I take the principal, multiply it by 1 plus R over N. So I'm going to take the rate divided by the number of times compounding per year, because you can compound monthly, quarterly, you can do it semi-annually. So there's different amounts of times per year you can compound. You can do it daily, quarterly, different number of compoundings per year can be different. So divide it by the number of times it is compounding per year, and then raise that. This parentheses gets raised to the number of times per year compounding times the time. All right, so here's, let's just do an example of that. Okay? All right, so let's see. Okay, so how much is in an account with $5,000 interest rate, $5,000 principal, interest, say 6% interest, compounded, quarterly for 20 years. How much is in the account with $5,000 principal, 6% interest, compounded quarterly for 20 years? Should say there. Okay, well, that would be A equals, what's my principal? Well, I said was 5,000. It's A equals, I erased it, P times 1 plus R over N to the NT power. So the principal is 5,000. It's 1 plus, now of course the rate, you don't want to stick 6 in there because you want to change the 6% over to decimal form. How to do that? 2 places back, 0.06. Use a decimal form of that. Okay, so N, remember N is the number of compoundings per year. So what's N here? Yeah, we're doing it quarterly, so N would be 4. N is going to be 4, so that's what I divide 0.06 by. Then I raise it to the 4 times N times T, so that would be 4, and the T is the time in years. It would be 4 times 20. So that's going to be 5,000 times 1, let's see, 0.06 divided by 4. Go and get that. It's 0.015, so 1 plus that is 1.015. And then raise that to the 80th power. Now, word of caution there, what do I do first if I'm doing this by hand or whatever? Remember, exponents are first. So I don't multiply 5,000 times 1.015. It's 1.015 to the 80th power, 3.29. How do you do that? Most calculators have like that button or a Y to the X button. Just hit 1.015, then hit either that, or you have one like that. Okay, and then that's 3.29 something times, then multiply that by 5,000. So I get 16,453.3 dollars. All right, it's 31. Okay. Now, let me make one quick point here, and then we'll talk about, there is another formula. Everybody got that one? All right, so let's say we've got, if, say 10,000 is invested at a rate of say 3.5% compounded monthly. How much is in it after $18 months? Well, formula says you take A equals, what's the principal here? 10,000, the amount you start with, is principal. 1 plus R, what it goes for R? Well, it's 3.5, but don't let that fool you. You still got to move it 2 places back, don't you? So it's 0.035 divided by N. What's N here? Well, it's compounded monthly. N is the number of compoundings per year. So if it's going by month, it would be 12 months, right? So divide by 12. And then raise that to the 12 times 1.5. Why 1.5, not 18? The formula is based on years. T is in years. This is months, so you change the months to years by, how do I do that? Well, you take 18 divided by 12. It's 1.5. Okay. All right, so that'd be A equals 10,000 times, and that'll be, may not be a very nice number there. See, 0.035 divided by 12. Oh, that's not too bad. Well, I don't think it's rounding off. Yeah. You don't want to round these off too much. This is not a nice whole number here. It's 1666666 repeating. Mine rounded off to 7, so I think that'll be okay. And then that's going to be 12 times 1.5 is 18. That's interesting there. All right, so take that plus 1, raise that to the 18th, then multiply by 10,000. Exponents first. I get $10,538 and 22 cents. Something like that. Okay? All right. There is another formula, though, and it does use the natural base, and it's used for what's called compounding continuously. That formula, one we just talked about, is the one you use for compounding quarterly, monthly, daily. There is continuously. And its formula goes A equals P e to the RT. It shortens up quite a bit if you have compounding not monthly, not quarterly, but continuously. Use this formula if compounding continuously. Which, just like it sounds, that means it's even better than doing it per second. This is just continuously compounding for so many years. T is, again, P is the principal, T is the time in years, R is the rate. What's E? The natural base. Yeah, that's the 2.71828 number. So it uses that that base there. And so PERT, I mean, that's a pretty nice little formula if you're compounding continuously. So let's say we've got $5,000. $5,000 is invested at 7.1% compounded continuously for 20 years. How much is in that account? Well, that would be just, since it's compounding continuously, this is the formula we use. A equals PERT, P-E to the R-T. So that'd be what? 5,000 times E to the, what's the R? Well, again, you got to move it 2 places back. Don't forget, even if there's a decimal already, move it 2 places back, so it's 0.071 times T, time in years, is 20. So it's 5,000 E to the, what would that be, 0.142? E to the 1 point, E to the 0.142? 1.42. Oh, 20, yeah, I'm sorry. Just checking. All right. E to the 1.42. So just punch that in. 5,000. 1.42. I get 20,000 something.